economy model for robots closely resembles successful platforms such as Uber and Airbnb, which have notably reduced personal asset ownership in urban settings. This innovative trend holds the potential to be replicated with Tesla Optimus robots. Furthermore, the introduction of public Optimus robots could have a transformative impact on various sectors, including hospitality and healthcare. By streamlining operations and enhancing customer experiences, these robots could effectively address the increasing demand in these industries. In addition to their operational benefits, renting Optimus robots for household chores offers individuals the opportunity to reclaim valuable time. This service is particularly beneficial for busy families and single parents, enabling them to prioritize personal pursuits. Moreover, Optimus robots possess the capacity to significantly enhance labor productivity in sectors such as service and logistics. Research indicates that they could potentially increase efficiency by as much as 30%, thereby alleviating workforce shortages. These robots also contribute to environmental sustainability initiatives by actively participating in recycling and waste management efforts. Their involvement can assist cities in achieving their green goals with greater effectiveness. Nonetheless, the public deployment of these robots presents challenges, including potential job displacement and privacy concerns. This necessitates the development of robust policies and regulations to ensure their safe and ethical integration into society. The advanced capabilities of neural networks and machine learning allow Optimus to adeptly adapt to manufacturing and healthcare roles, significantly reducing the occurrence of workplace injuries. This adaptability is paramount in the context of modern automation. Constructed from resilient materials such as 7075, T6 aluminum alloy and carbon fiber reinforced polymer, Optimus is engineered for enduring performance under the rigors of daily use. This durability ensures the robot's reliability over an extended lifespan. Additionally, the optimization for energy efficiency through an advanced battery management system enhances the robot's operational longevity. This allows for effective functioning on a single charge, thereby contributing to sustainability objectives. Optimus employs a sophisticated neural network to monitor real-time joint stress, subsequently redistributing tasks among its limbs. This feature is vital for ensuring the protection and durability of its hardware during various operational scenarios. Tesla subjects Optimus to comprehensive testing procedures, including exposure to extreme temperatures and simulated operating hours, in order to identify potential weaknesses prior to mass production. This rigorous approach ensures high reliability and minimizes downtime in real-world applications. The integration of Grok Voice AI empowers Optimus with natural language processing capabilities, facilitating fluid conversations and effective assistance for users, including seniors and children. This adaptability significantly enhances its usability in diverse contexts. Furthermore, the redesign of Optimus Gen 3 prioritizes manufacturability and cost-effectiveness, crucial factors for scaling up production. This strategic approach aims to sustain a competitive price point of $20,000. Optimus Gen 3 also introduces a new hand with 22 degrees of freedom, which greatly enhances its functionality for a variety of tasks such as cooking and cleaning. This improvement allows the robot to perform an expanded range of household activities. Additionally, Musk's strategy involves leveraging Tesla's extensive logistics network to repurpose components from electric vehicles, with the goal of achieving mass production. This synergy between technology and manufacturing has the potential to redefine robotics on a large scale. Elon Musk envisions a future where 2 humanoid robots exist for every individual, thereby setting ambitious production targets of up to 1 billion units annually. This vision reflects Tesla's commitment to innovation and scalability. Optimus robots are projected to assist across various sectors, including healthcare and retail, optimizing essential tasks such as medication delivery and inventory management. This versatile functionality emphasizes their potential market impact. Finally, investors are increasingly directing funds towards robotic startups, with projections indicating that the humanoid robot market may reach a valuation of $38 billion by 2035. This trend underscores the escalating interest in automation technology and its implications for the future. The design of the Optimus Gen 3 is engineered to achieve a level of realism that closely resembles a human in a robotic suit, effectively blurring the boundaries between robotics and human characteristics. This innovation incites stimulating discourse regarding the potential role of robotics in everyday life. Musk has delineated ambitious production targets for subsequent iterations of the Tesla bot, aspiring to produce 10 million units of Gen 4 and up to 100 million for Gen 5. This intent underscores Tesla's unwavering commitment to advancements in the field of robotics. Significant technical challenges have emerged in the development of the robot's hands, reflecting the intricacies involved in achieving human-like dexterity. This highlights the engineering complexities that must be addressed to advance humanoid robotics. Optimus robots possess the capability to operate continuously, yielding approximately 8,760 hours of productivity annually, in stark contrast to the average human work output of 2,000 hours. This disparity accentuates the considerable productivity differential between robotic systems and human labor. Musk posits that the consistent performance of Optimus has the potential to eliminate human error attributed to fatigue and stress, thereby rendering it particularly suited for tasks that demand precision. Such a trait could substantially augment productivity across various sectors. The uninterrupted connectivity of Optimus facilitates collective learning among robots, thereby enhancing the overall efficiency of the system. As an increasing number of robots operate, they exhibit improved intelligence, which could revolutionize industrial processes. Musk's $1 trillion compensation framework reflects his profound confidence in Tesla's capacity to spearhead a robotics revolution poised to transform the economy. This ambition is deeply rooted in a clearly defined production timeline. The absence of a dedicated supply chain for humanoid robots necessitates that Tesla engage in extensive vertical integration within its manufacturing processes. Although this poses substantial challenges, it is well aligned with Tesla's operational capabilities. Musk's advocacy for advanced robotics is rooted in a desire to ensure that AI development remains congruent with human values. He perceives his influence over Tesla's trajectory as crucial for the safe evolution of artificial intelligence. The Gen 3 Tesla bot is poised to feature 3 distinct models, each tailored to efficiently manage a variety of household chores, including cooking and cleaning. This innovation aims to redefine the landscape of home automation. Musk has underscored the necessity of designing a robot that does not elicit the uncanny valley effect, choosing a simplified aesthetic to promote approachability. This consideration is essential for integration within family settings. The Gen 3 iteration incorporates substantial advancements in robotic hand design, now outfitted with 22 miniature motors, thereby allowing for unprecedented levels of dexterity and precision in task execution. This enhancement distinctly sets it apart from earlier models. Equipped with advanced learning capabilities, the robot is able to comprehend and carry out intricate tasks, such as cooking and cleaning, with remarkable fidelity based on its past experiences. This adaptability positions it as a versatile home assistant. Optimus Gen 3's interactive features, which include a facial display and integrated voice communication, enable it to engage with users in a natural manner, adjusting to their preferences and personalities.
Such human-like Interaktion fosters a deeper connection.
Despite its advanced capabilities, Optimus Gen 3 encounters several challenges, notably in terms of movement speed, which has proven to be slower than anticipated for a home assistant. Enhancements in mobility are imperative for achieving optimal efficiency. Tesla's extensive expertise in manufacturing electric vehicles and robotics positions it to produce the Optimus robot efficiently and at a lower cost than its competitors. The existing production systems are instrumental in facilitating this process. The Optimus robot is adeptly designed for both industrial and domestic applications, showcasing capabilities that could effectively alleviate labor shortages and transform various sectors. This versatility significantly enhances its appeal to businesses. Elon Musk's forward-looking plans for future iterations of Optimus encompass substantial enhancements in mobility and AI integration, which may broaden its applicability in sectors such as healthcare and education. Such advancements could fundamentally reshape the labor landscape. Elon Musk envisions the Tesla bot as a multifunctional entity capable of executing a variety of tasks that promise to save users both time and financial resources in their daily routines. This versatility is designed to significantly improve the quality of life for many individuals. In spite of its promising capabilities, consumer skepticism persists regarding the bot's effectiveness and overall value. Many potential buyers express concerns about whether it will fulfill its projected role beyond being merely advanced technology. The design of the Tesla bot prioritizes human-like movement and functionality, employing electric drives to create a natural and engaging workout experience. This innovation signifies a notable progression in the field of humanoid robotics. The robot's sophisticated sensory abilities empower it to modify workout routines in accordance with individual performance metrics, thereby enriching the training experience. This feature provides a level of personalization previously unseen in fitness technology. With 22 degrees of freedom and enhanced tactile sensors, Optimus is equipped to perform delicate tasks that necessitate human-like precision. This advancement paves the way for robots to assume responsibilities traditionally reserved for specialized professionals. Optimus Gen 3 is also capable of extending its functionality to household tasks, such as cooking and cleaning, thereby streamlining daily chores. This multifaceted versatility positions it as a valuable companion within the home. Optimus can navigate through traffic and execute driving tasks, thus ensuring safety for older adults who may experience mobility challenges. This technology provides a much-needed solution for individuals hesitant to drive independently. The robot's advanced sensors are designed to monitor the physical well-being of passengers, alerting them and their families to potential health concerns during transit. This feature significantly enhances the safety framework for elderly users. Furthermore, Optimus effectively addresses the issue of isolation by providing companionship, which may mitigate feelings of loneliness among senior citizens. This integration of transportation and social interaction offers holistic support for users, a competitive advantage in the field of robotics. The company's ambition is to manufacture billions of robots, potentially revolutionizing mass production capabilities across various industries. In the realm of healthcare, the Tesla bot exhibits the capacity to analyze extensive medical datasets at a pace far exceeding human capabilities. This efficiency not only conserves time for researchers but also enhances the accuracy of pattern recognition and relationship identification within the data. Furthermore, in disaster scenarios, Tesla bots demonstrate exceptional proficiency in executing search and rescue operations. Their effectiveness significantly elevates the likelihood of locating survivors in perilous environments following natural disasters. In addition to their capabilities on Earth, Tesla bots are equipped to undertake complex tasks in the realm of space exploration. They can perform repairs on space stations and collect samples from other planets, thereby mitigating risks faced by astronauts during missions. Within the healthcare sector, Tesla bots can facilitate precision surgeries, enable personalized treatments, and provide efficient remote patient monitoring. These advancements hold the potential to significantly enhance overall patient care and outcomes, illustrating the technological synergy essential for contemporary medical practices. In industrial environments, Tesla bots optimize production processes, improve logistics, and enhance safety by managing complex tasks. Their proficiency in navigating intricate operational landscapes represents a transformative shift in operational efficiency. Finally, the integration of Tesla bots into educational settings fosters immersive learning experiences, offers personalized tutoring, and facilitates virtual simulations that transcend traditional classroom boundaries. This innovative approach significantly boosts student engagement and enhances knowledge retention. Remarkably high speeds, thereby improving its overall operational capabilities. Furthermore, the integration of high-resolution cameras and advanced sensors within the Optimus head facilitates precise identification of objects and potential hazards. Such specifications are crucial for ensuring the robot's navigation and safety in various environments. In addition, the lightweight structure of Optimus 5.3, which weighs approximately 125 pounds, significantly enhances its maneuverability and energy efficiency. This aspect is particularly vital for ensuring safe operations in human-dominated environments, thereby promoting effective mobility. Moreover, Optimus Gen 3's walking speed is intentionally designed to be slower than that of humans, with a primary focus on stability and precision. This design choice is especially important in environments such as warehouses and factories, Gen 3 integrates cutting-edge battery technology, which enables it to operate for durations exceeding those of any humanoid robot currently available on the market. This significant advancement effectively addresses the energy consumption challenges that have historically plagued other robotic systems. In this context, Elon Musk envisions a transformative future wherein robots undertake all forms of physical labor, thereby allowing humans to concentrate exclusively on management and strategic decision-making. Such a paradigm shift could fundamentally redefine societal notions of work and income distribution. Moreover, the potential applications of the Tesla bot extend far beyond mere productivity enhancements. It could serve as a solution to pressing societal challenges, such as poverty alleviation and improved healthcare access. By fundamentally altering human lifestyles and economic structures on a global scale, this innovation promises significant implications. Furthermore, the weight reduction achieved in the Optimus Gen 2 contributes to enhanced energy efficiency, enabling the robot to execute more intricate actions while maintaining a comparable battery capacity. This modification exemplifies Tesla's ongoing commitment to optimizing the performance of its robotic systems. As for Optimus Gen 3, it is anticipated to incorporate a 4680 battery cell, potentially extending its operational time to 14 hours. This advancement not only illustrates Tesla's dedication to enhancing the endurance and functionality of its robots, but also positions Optimus as a formidable asset in various applications. The forthcoming commercial release of Optimus is poised to empower the robot to undertake an extensive array of household tasks, while also demonstrating potential utility in medical settings. This versatility highlights its promising role as both a domestic aid and a healthcare support companion. Additionally, Optimus' capacity to interpret human gestures facilitates intuitive interactions, which proves particularly beneficial for users facing communication challenges. For instance, simple gestures such as pointing can elicit specific, programmed responses from the robot. Elon Musk posits that as production scales up, the cost of Optimus could decrease significantly, thereby enhancing its accessibility for a broader consumer base. The ambitious objective is to manufacture 1 million units annually, which could spur widespread adoption. The integration of Tesla's state-of-the-art 4680 battery technology endows Optimus with capabilities that are unmatched by existing robotic solutions, thereby enhancing its attractiveness for both commercial and personal applications. Moreover, Optimus is projected to serve as a cost-efficient alternative for executing labor-intensive tasks. This innovation allows owners to recoup their investments swiftly through significant gains in efficiency and productivity. The versatility of Optimus, capable of functioning across various sectors, including restaurants and warehouses, underscores its potential to optimize operations within diverse industries. Such adaptability positions it as a valuable tool in modern business environments. Nevertheless, ensuring the safety and security of a humanoid robot like Optimus is paramount. This presents unique challenges, particularly concerning safeguarding against cyber threats and ensuring safe interactions within human-centric environments. To address these concerns, a multi-layered security architecture is employed, incorporating encryption, real-time monitoring, and AI-driven firewalls. These measures are designed to thwart unauthorized access and ensure the secure operation of the robotic systems. Additionally, the learning capabilities of Optimus introduce distinct challenges related to the prevention of misuse or tampering. Therefore, prioritizing ethical AI development alongside robust cybersecurity measures is essential for the safe deployment of these advanced robotic systems. In conclusion, Elon Musk emphasizes that Optimus will only be released to consumers once it adheres to stringent safety standards. This underscores Tesla's unwavering commitment to prioritizing user safety and ensuring the responsible integration of robotics into everyday life. Gen 3.5 fundamentally transforms household management, reducing the time required for chores to a mere 5 to 10 minutes per day. By automating essential tasks such as cleaning, cooking, and laundry, it significantly enhances convenience for its users. Moreover, Optimus seamlessly integrates with Tesla energy systems to optimize household energy consumption. It possesses the capability to schedule household tasks based on fluctuating electricity costs or availability of surplus solar power, thereby promoting overall energy efficiency. In addition to energy management, Optimus serves as a valuable support system for elderly and childcare needs. It continuously monitors vital signs and is equipped to respond promptly to emergencies, fulfilling the dual role of a family assistant while ensuring a safe environment for children. The robot's safety monitoring extends beyond mere supervision. It is adept at detecting potential hazards and actuating emergency responses, thereby fostering a secure atmosphere for both children and the elderly. This continual vigilance plays a critical role in preventive measures. Furthermore, Optimus Gen 3.5 is specifically designed to cater to individuals with mobility impairments, effectively enhancing their independence in daily activities. Its personalized approach allows for adaptation to individual user needs, ensuring effective support. In the context of a post-pandemic world, Optimus significantly contributes to home productivity by managing distractions and optimizing the work environment. Its integration with smart home systems serves to enhance focus and overall efficiency. Additionally, Optimus proves to be an invaluable aid during presentations, adept at setting up cameras and adjusting audio settings to achieve optimal results. This capability simplifies the process, allowing users to concentrate on delivering their content effectively. The robot also facilitates a healthy work-life balance by seamlessly transitioning between modes, such as playing music or preparing dinner, ultimately minimizing stress after working hours. Finally, with its predictive maintenance capabilities, Optimus proactively alerts users to potential appliance issues before they escalate, effectively saving costs and extending the operational lifespan of household appliances. Optimus's ability to maintain balance on uneven surfaces exemplifies substantial advancements in both mechanical design and artificial intelligence systems, which are crucial for practical applications in the real world.
This progress signifies a remarkable evolution in the realm of robotics technology.
In comparison to earlier generations, Optimus has achieved an impressive 70% increase in movement speed. This enhancement underscores Tesla's commitment to refining human-like mobility and agility within their robotic designs. Moreover, Tesla strategically utilizes its logistics and electric vehicle components to establish